Chapter 4, Video 2, Administering a Graded Exercise Test. This video will discuss how to get started with administering an exercise test, some keys for when to stop, and different general types of tests. So when you have a client come in for a graded exercise test, there are a couple steps before you get them up and going. First is generally some informed consent and preliminary screening. So you want to make sure that they understand the protocol that you're going to put them through and have some idea of their general health and fitness background. So you may ask about their current exercise level, what types or modes of exercise that they do, and of course any history or family history of heart disease or risk factors or other concerns. You're then going to gather resting data, generally a resting heart rate and perhaps a resting blood pressure. This is good to get an idea of where they're starting so that after the test, when you have them recover, you know if they're heading back towards their normal numbers. You'll then have them complete a 2 to 3 minute warm-up. This is, if you're doing a treadmill test, generally just a slow walk to get them used to it, especially if they've never been on a treadmill before. You may make this stage just a little bit longer to get them comfortable on the treadmill. And then 3 things that you will usually monitor at every stage of the test is heart rate, blood pressure, and their RPE, their rate of perceived exertion. And you'll generally measure this in the last minute of the stage. Often stages are either 2 or 3 minutes. And the reason we measure it at the end is we want to give their body time to adjust to the demands of that specific stage. So if we measure it right after we change the speed or the incline, their heart rate, their blood pressure, and certainly their perception of how hard it is hasn't really had time to adjust to that new demand. So we measure it at the end of the stage. You also want to talk to your client. RPE is a part of this. You're asking them how hard does it feel to you, but you want to ask them easy questions, make sure they're doing okay. You don't really want them talking a whole lot, so nice short questions. You're also going to watch them, make sure that they look like their stride is steady and strong, that they're not struggling on the treadmill. Watch for any changes in breathing, see if they get really flush really fast, anything that might cause concern. There are a couple reasons for stopping the test. We'll talk about more specific ones in a minute, but here are kind of the general big 3. Is there a predetermined endpoint? Especially if you're just doing a submax test. You may only do a few stages and then you just know you're going to stop. Or maybe there's a certain clearance point that they have to get to. So as long as they get to a certain VO2 point, that's all you need to know. And as long as they're that fit, you're okay, and you might stop there. Certainly if the client requests to stop, so whether they're just generally tired, they feel like they're having trouble breathing, a common thing, especially for some of the protocols that include big hills, is they'll have calf cramps and maybe they just feel like they need to stop. And then any of the clinical indications that we'll talk about in a few minutes, where things look like they're heading in the wrong direction. We want to stop that test before anything bad happens. Regardless of what your reason for ending the test was, you're then going to give them a cool down period and continue to monitor heart rate and blood pressure, and again, make sure that those are coming back down towards normal. There are a couple different ways or different scales for assessing perceived exertion. For those of you that have done the maximal exercise test in class, you probably used the Borg scale, and I get a lot of questions about this funny scale. So the Borg rating of perceived exertion, RPE, generally, or the original scale ran from 6 to 20, which is a really weird scale. The reason for it to be 6 to 20 is it was intended to correspond with typical heart rates at those intensities. So if we add a 0 on to every number, resting heart rates in general, certainly not for everybody, but in general, are around about 60 beats per minute, and maximal heart rates of about 200. Now this is of course dependent on fitness level and age, but it's just a general ballpark. Now because that 6 to 20 scale is so weird, there are a number of 0 to 10 scales that have been developed instead. But let's look at the 6 to 20 one first. So this is the original Borg scale, and you'll see that for every rating there is also some description of what that feels like. Again, because 6 to 20 is such a weird scale. So 6 is standing still. They're not resting, but they're not moving at all. There's no exertion. And generally you want to ask them kind of to give you an idea of full body exertion. If they feel like it's just kind of light, 11 is a good point there. If it's getting hard, they're going to be 15 or higher. And our goal is generally to get them to 18 or higher on a maximal test. So we saw that one of our criteria for max was an RPE above 17, so 18, 19, or 20. 20 is usually where they just say, I'm done. So you may not record a 20, they're just going to tell you we're stopping the test. There are, as I said, a couple 0 to 10 scales. So the Omni RPE scale was developed to work on a 0 to 10 scale. And there are examples here of some of the language that go along with those points along that scale for both adults and children. So different descriptors there. There are also scales that include graphics or cartoons for kids. So one that I'm familiar with is a kid riding their bike up the hill, and you can see their face is just getting more and more exhausted and tired and red as they go up that steeper and steeper hill as they get close to 10. So a couple different scales to use, but we do want to assess RPE so that we know how the client is feeling during the test and not simply going off of these physiological markers. As I mentioned, there are a number of specific reasons for stopping a test. So angina or chest pain, certainly if our client is saying that they're starting to feel things happening in their chest, we probably want to stop the test. As you're measuring blood pressure at each stage, you want to not only look at their overall blood pressure, but how it changes from stage to stage. Systolic blood pressure should increase as the demand or the intensity gets harder. Diastolic blood pressure will generally stay about the same throughout the test and may actually drop a little bit. So if you see a drop in systolic blood pressure where it should be going up, that's a reason to terminate the test. And then if blood pressure generally gets over 250 for systolic or over 115 for diastolic, that's just too high and it's time to stop the test. If they complain of shortness of breath, or you're noticing poor oxygen perfusion, they're having maybe some issues with tingling in their fingers or toes, that's also a reason to stop the test. If the heart rate stops rising, again, this is sometimes evidence of a plateau, and once we have a plateau, we can stop, but if we don't think they're at max and their heart rate is not responding, that's certainly a concern. If we have abnormal heart rhythm, now you're only going to know this if you also have them hooked up to an EKG machine, but certainly if we're showing abnormal rhythms happening in the heart, we need to stop the test. Always, if the client requests, we're going to allow them to stop. If they're severely fatigued, whether they tell us that or we can see it, that's a reason to stop. And of course, sometimes you have to stop the test because something funky happens with maybe the treadmill or some other measurement equipment. So lots of reasons why you may have to stop. And generally, we just want to make sure that we're recording what that reason was. All right, let's talk about some of the different kind of general categories of graded exercise test protocols. The first and most common, and the type that you do in lab for this class, is a continuous protocol. Our goal here is for the test to be about 8 to 12 minutes long. And the idea here is we don't want it to get too long because we don't want our participant to stop simply because the test got so long that they're tired. We want it to be that the demand or the intensity got to be too much for them. So we don't want it going certainly past 20 minutes is too long. You're generally going to have 2 to 3 minute stages here, and each stage is going to increase by about 2 to 3 METs. So remember, those metabolic equivalents or multiples of intensity at rest. We're going to go up a little bit every stage of this test. Again, there are a lot of specific protocols that fall into this category that we'll talk about in future videos, but here the treadmill is continuously rolling, but you're going to those 2 to 3 minute stages, so every 2 to 3 minutes the demand increases. Slightly different from that is a ramp protocol. So we're still moving continuously here. We're shooting for about a 10-minute duration, and the difference is instead of increasing every 2 to 3 minutes, we're basically continuously increasing the demand. So every 10 to 20 seconds, there's going to be a small increase in the intensity. These are less common than the continuous protocols, and that's because they generally need to be done with a electromagnetically braked cycle or bike, or a programmable treadmill where the treadmill is hooked up to a computer and you just start the test and it's going to slowly increase the treadmill as you go every 10 to 20 seconds. Because of this small continuous increase, VO2 plateaus are harder to identify in a RAMP protocol, and so that might not be the best criteria for stopping the test, and certainly we may not have VO2 max language used here. We might call it a VO2 peak because we don't have the plateau. And then the third protocol is a discontinuous protocol. So here we actually have rest periods between the different stages. And so you may be on the treadmill for 2 or 3 minutes and then stop for a minute or two so that we can measure a couple other variables. So if you're measuring blood pressure during the test, it is a lot easier if you have them stop between each stage and measure it. We can still take blood pressure during continuous protocols. It's just easier during a discontinuous protocol. And then if you're measuring blood lactate, we often do this with a fingertip prick blood draw, and that's a lot easier to do if their hand is not moving as they walk or run on the treadmill. It's important to note though that these protocols usually take longer, probably closer into the range of 20 to 30 minutes because you're stopping and they get a chance to recover between each stage. So here's a picture of what it looks like in between the stage here. You can see that they've pulled a chair up onto the treadmill. The person on the far side is taking their blood pressure over there, and the person over here is measuring blood lactate. So this is the protocol that we used when I did athlete testing at Michigan State University. We tested both basketball teams and the hockey team every season. And they'd come in and they'd do a 3-minute exercise stage, and in between every stage they stopped for a minute and a half so that we could take these measurements. And then they'd get up, we pull the chair off, and they start going again. You still have the same criteria regardless of what type of protocol you're doing for stopping the test. You know, if they have any of those clinical indications, or just once they reach fatigue. It's just the general setup of these protocols are a little different. That's the end of video 2.